So, you want to know how to use the tools, am I right? Well then, you're in luck, because this video is all about the 9 tools we have for calculating angles. So grab your toolbox and let's start the video. First, let's take a look at the tools in our toolbox. Right angles, straight angles, full angles, opposite angles, the bisector, the triangle sum, and the base angles in an isosceles triangle. And together with alternate angles and corresponding angles, we have a total of 9 tools at our disposal. I say 9, but actually with the quadrilaterals of paragraph 7.4 we do have a few extra, but I'm not going to put them on my list here. In today's video I will give you a few exercises of my own to practice. I have chosen 3 exercises from this chapter, modified them and made up 3 new ones to help you understand how to use your toolbox and how to write down all intermediate steps. Before we start, a small disclaimer. Most exercises can be done in a different way. For example, maybe you use the bisector to calculate an angle instead of the triangle sum. That's totally fine as long as the answer is correct and you've written down all intermediate steps. So to help you, I will show you a few of the other angles in case you use a different method. Ready for the first one? Well, here it is. This here is the isosceles triangle ABC. I've given you some information in the form of symbols, and with this you should be able to calculate angles A1, D1 and E3. Pause the video if you want to give it a try, and when you're ready, I will show you how I solve this problem. First, angle A, which is 35 degrees. And how did I do that? Well, first I noticed that angles A12 and B are the base angles of the isosceles triangle and thus the same. And because A1 and A2 are equal thanks to the bisector, both of them are 35 degrees. I then used a corresponding angle pair to figure out the angle of size D2, which is then 70 degrees. As D12 is a straight angle, D1 is 180 minus 70, which is 110 degrees. To find the answer for E3, I took a look at triangle ABC. I know A12 and B are both 70 degrees, so C should be 40 degrees. And now I can use the triangle sum in ACE to figure out the size of angle E3, which is 105 degrees. And there you have it, one big exercise in just a few moments. And these are some of the other angles you might have calculated. Ready? Then on to the next one. This here is the right angle triangle KLM with K equal to 90 degrees and L equal to 63 degrees. Furthermore, LM and NS are parallel and KP and MP are equal in length. Your goal, should you agree, is to calculate the angles S2, R4 and P2. Good luck! I like to start with the triangle sum, so I can calculate the size of angle M, which is 27 degrees. I then found this corresponding angle pair, so I know that S2 is equal to M. So angle S2 is also 27 degrees. Angle R4 can be found in triangle KRS, and I already know S2. As KP and MP are equal, that means KPM is an isosceles triangle, with K and M being the base angles. And this means that angle K1 is also 27 degrees. And with those two angles known, I can calculate the size of angle R4. 180 minus 27 minus 27 is equal to 126 degrees. Angle P2 can be calculated in several ways. I started by figuring out angle R1 with the straight angle rule, and then using the alternate angle pair with P2, meaning angle P2 is equal to 54 degrees. And here are a few of the remaining angles. For our last exercise, let's take a look at rhombus ABCD. Angle D is 118 degrees and B1 is 44 degrees. Go calculate angles C1, S2 and B3. Good luck! Although you don't see the symbols, AD and CD are actually the same length. How do I know? Well, because the exercise states that ABCD is a rhombus, and all sides of a rhombus are equal, meaning with diagonal AC drawn, triangle ACD is an isosceles triangle. So, first I calculate the remaining degrees for both A1 and C1. That means that both of these angles are 31 degrees. And because AC is the diagonal, angles A1, A2, C1 and C2 are all equal to each other. This causes me to be able to calculate the size of angle S4 in the smaller triangle. 180 minus 31 minus 44 is equal to 105 degrees. And angle S2 is opposite of angle S4, so angle S2 is also 105 degrees. To figure out angle B3, I managed to find this F shape. And because angle A12 is equal to 62 degrees, by law of the corresponding angle rule, angle B3 is also 62 degrees. And here are some of the remaining angles in case you took a different angle of approach. And that's how you use your toolbox and how to write down all intermediate steps. I hope to see you in the next chapter. Good luck!